Okay, so what we're covering for today, we are going to be discussing multiplication and division rules. So we've already gone over our addition and subtraction. We're going into our multiplication and division real quickly. So today, our learning statement is going to be that you can multiply and divide integers using integer rules. I can convert fractions to decimals through division. So being able to do that conversion is a really big component for our unit. So we really want to make sure you guys understand that. We're going to practice it using our calculator, but also understanding the process. So as we are going through here, multiplying integer rules, and I want you to make sure you understand that this is also for division. Quick. Yeah. These rules also apply for the division. Now, you can set it up as a grid or you can use the triangle down below, but either way, these are the rules that we follow. If you have a positive and you are multiplying it by another positive, multiplying or dividing, I'm going to put a little division sign there too. Multiplying or dividing, remember this is true for both, then you're going to get a positive answer. So positive times a positive gives you a positive divided by a positive will give you a positive. If you have a negative and you're multiplying or dividing by a negative, that also will give you a positive. So double negatives are going to give you a positive. This again is only true for multiplication and division, not for addition and subtraction. We know that if we add two negatives, we still have a negative. But when we multiply those negatives, the negatives negate each other out. If we have a positive and we multiply or divide it by a negative, it will result in a negative. And if we have a negative and we multiply it or divide it by a positive, that will give us a negative. So you have this grid that you could memorize, or you could do the easier thing. A lot of people like the triangle. The triangle has three corners. In one corner, we place a positive symbol, and at the other two corners, we place a negative symbol. And when we multiply or divide, two integers, all we have to do is cover them up. If I multiply a positive number, so I'm going to cover a positive because I'm multiplying a positive, times a negative, what's the only thing left showing? A negative. So positive times a negative gives me a negative. If I multiply a negative times a negative, what answer is it going to give me? A positive, because the positive is remaining. The triangle is a really easy thing because you can draw it very quickly at the top of your paper. Draw the triangle, plus sign, two minus signs, and there you have it. But again, it only works for multiplication and division. Okay, with that in mind, without using your calculator, I do not want you to use your calculator. I want you to go ahead and do these 6 problems on your own, understanding whether they're going to be a positive or a negative. So for here, for problem number 1, we have a negative that's getting multiplied by a positive, so that's going to equal a negative. So negative 3 times 2 is going to give us a negative 6. For problem number 2, we have a negative that's getting multiplied by a negative. That's going to be equal to a positive. And 5 times 4 is 20, so we get a positive 20. Problem 3, again, we have a negative multiplied by a negative. That's going to give us a positive. And if we do 20 times the 6, that comes out to 120. For problem 4, we have a negative divided by a negative. That will equal a positive. And 20 divided by 5 comes out to 4. We've got problem 5. This is a division problem. Keep in mind that fractions are division problems. Okay, the numerator gets divided by the denominator. Numerator always gets divided by denominator. So basically this is reading 24 divided by negative 6. So we have a positive that's getting divided by a negative, and that's going to come out to a negative. So we get -4. And the -32 divided by a +4, so we have a negative that's being divided by a positive, and that's going to come out to a negative. So we'll get -8. All right, let's go ahead and flip it on over to the back. We're going to take a look at some key vocabulary words. Some key vocabulary words that go along with multiplication and division. So for multiplication, you've got a bunch of phrases that can represent a multiplication problem. So obviously, multiply and times, those are ones that you've heard quite often. Product, you've probably heard. If I say I'm doubling something, what am I multiplying by? If I'm going to double it, what am I multiplying by? By 2. If I triple something, what am I multiplying by? By 3. When I say something's happening twice, that's also a multiplication by what? Twice. Somebody said 3, but that's not correct. 2. Okay? When we talk about area, area is a multiplication problem. And then the word by, that's an uncommon one that's not used very often that we've seen, but you will see it a lot in contextual problems. The word by can represent multiplication. Then we've got division. So our key vocab words for division, we've got quotient, equal parts. Whenever you see a problem is discussing that we're going to take this into equal parts, that is a division problem. Obvious words of divide, that's going to be division as well. If we take half of something, then we're dividing it by 2. Just the same as if we take a third of something, we're dividing by 3. A fourth of something, we're dividing by 4. If it goes into, how many times does this go into that? That's a division problem. And then when we're talking about ratios, ratios are set up as a division problem. Hence the fraction. Fractions are your common ratios. All right, so what I'm going to do is we're going to go over just a couple of little problems here. For vocab words, we're going to identify key vocabulary terms. We're going to also identify integers so that when we're setting up our multiplication or division problems, we know which values are positive, which values are negative, and what operation we're utilizing. So Elena overdraws $25 on her account every day for 4 days. Overdraws. If I'm overdrawing in my account, is that a positive or a negative? Negative. When I overdraw on an account, that is going to represent a negative. And she's going to do this for a period of 4 days. Days. Are days positive or negative? Positive. Because it's time, right? Time is always positive. Time is always going to be a positive value. We want to know how much total is in her account overdrawn by. She's going to do this every single day. So that keyword every can represent multiplication. Okay, remember these were just a couple of little phrases here that we can use, but every is also another phrase that can be utilized as a multiplication problem. We're doing this today, we're doing it tomorrow, we're doing it the next day, we're doing it for the 4th day, 4 days in a row. So we're multiplying here. We're going to take -25 and we're going to multiply by a +4, and that's going to come out to a -100. We identified our integer values, we identify the operation, and then we get to work. All right, Alex's team lost a total of 54 yards in the first quarter. All 9 players lost the same amount. How much did each player lose? Okay, so let's start with 54. 54 is what kind of value, positive or negative? Alex's team lost a total of 54 yards. Is it positive or negative? Negative. Okay, lost 54 yards. That's going to be a negative. All 9 players. We're talking about people. Are people positive or negative? Positive. All 9 players. That's going to be a positive. Now they all lost the same amount. What operation would that be? They all lost the same amount. Divide, right? Equal parts. We're talking about equal parts. So if they all lost the same amount, we're dividing. So negative 54 divided by 9. And that's going to come out to negative 6. So we have negative 6 yards per player. It's always good to identify what it represents. Negative 6 yards per player. I want you guys to go ahead and do problems 3 through 5 on your own, please. Or 6, sorry, 3 through 6. There's problem 6 is on the other page. And I apologize for 4 and 5 being so packed up together. For problem number 3, a temperature falls 3 degrees each hour for 8 hours. We want to know what's the total change in temperature over this 8-hour period. So the fact that it falls 3 degrees, that's going to be a negative. So I'm going to go ahead and highlight or underline that in pink. It's going to do this for a period of 8 hours. Again, time is always positive. And it's going to do it every hour for, 8 hours. That means that we're going to be multiplying because we're trying to find the total. We're trying to find that total. We're going to go ahead and multiply them. So when we multiply, we're going to get negative 24 degrees total dropped. Negative 24 degrees total in the drop. Okay, a submarine dives 20 meters each minute for 15 minutes. We want the total change in depth after 15 minutes. Okay, again, dives. Dives is going to represent that negative. It does this for 15 minutes. Minutes represents a positive. It's going to keep doing this over and over again for 15 minutes. That means we're multiplying. So we have negative 20 that's going to get multiplied by, because we're looking for that total, multiplied by the 15. And that's going to come out to a negative 300 meters. Max lost 24 pounds in 8 weeks on his new weight loss plan. We want to know what was his average change in weight per week. So he lost 24 pounds over a course of 8 weeks. We want to know how much was it for every single week. What operation would that be? Division. Lost 24 pounds over the course of 8 weeks. We want to know it per week, so that means that we're going to be dividing. So we're taking that 24 pounds that he lost, which is negative, and we're going to divide it by the 8 weeks, which was time. That's positive. And when we divide, we come out with negative 3. So negative 3 pounds per week. Negative 3 pounds per week. All right, we go on to the last page. Problem 6 is located there. It says, Keither borrowed $4 a day until he had borrowed a total of $88. We want to know how many days did he borrow money. So he's borrowing money. If you're borrowing money, is that positive or negative? Negative. Borrowed money is negative. He borrowed $4, and he did this until he had a total amount borrowed of $88. We want to know how much money did he borrow each day. So how many days was he borrowing money? Okay, so this is going to be division. We're taking the negative 88, and we're going to divide it by negative 4. And that's going to come out to a positive 22 days. And remember, days are always going to be positive. Anybody still need this part, this sheet right here? Problems 1 through 5? No? Okay, so I'm going to go here. All right, what we're going to do now is we're going to talk about setting up fractions and converting them into decimals, looking at what the division problem looks like. Taking a look at the division problems. And then we want to identify which problem or which division is not like the other, which one is not like the rest. So let's take a look here at the very first example that we have. We have a negative sign in front of the fraction, and we have 3 over 5. Then we have a negative 3 at the top of our fraction for our numerator, and 5 for the bottom, which is our denominator. Then we have a positive 3 for our numerator, a negative 5 for the denominator. And then the last one, we have a negative 3 for the numerator. We also have a negative 5 for the denominator. We want to know which one is not going to be like the others. Okay? So when we set this up as a division problem, if you have the negative sign in front of the fraction, then when you're dividing, it's like you're putting a negative sign, and then you're doing parentheses, and you're taking 3 divided by 5. So what I want you to do right now is I want you to set that up in your calculator. So take your calculator and type it out just as I just wrote it. Do the negative sign. Let me grab a calculator so you guys can see too. We're going to do the negative sign. Then we're going to do parentheses, 3 divided by 5, and close parentheses. So this is what it looks like here. My negative sign's down at the bottom. I got my parentheses, 3 divided by 5, close parentheses. So you guys see the screen? There's a negative in front, parentheses, 3 divided by 5, and hit enter. And you're going to get negative 0.16. So I want you guys to write that down. You have negative 0.6. Okay, for the next one, the negative is actually placed with a number, isn't it? It's placed with a number, so that means we're actually going to do negative 3 divided by 5. Type into your calculator, negative 3 divided by 5. In your calculator, do negative 3 divided by 5. What do we get? Say it out loud. Negative 0.6. Same thing, right? Got the same thing. All right, let's do the next one. Here we have a positive 3, and it's being divided by a negative 5. Positive 3 being divided by a negative 5. What do you think that's going to equal? If you do a positive 3 divided by a negative 5, what do you think that comes out to? Negative 0.6. Okay, for the last one we have a negative assigned to both of them. So if I do a negative 3 divided by a negative 5, am I still going to get negative 0.6? No. What is it going to become? 0.6, right? Positive 0.6. So the one that does not belong is right here. Having these double negatives, you have 2 negatives in the problem. That creates a positive in your answer. So each of these values comes out to being negative. The only one that comes out to positive is when you have 2 negatives in there. So the bases are the same, right? The number values are the same, but the sign is different. It's important to understand that the placement of your negative does not matter. It does not matter if you put the negative in front of the fraction. It does not matter if you put the negative at the top of the fraction. It does not matter if the negative goes at the bottom of the fraction. What does matter is how many negatives you have. If you only have 1 negative, then your answer is a negative. But if you've got 2 negatives in a fraction, the answer is positive. All right, Let's take a look real quickly. I know that this one says over 7. Go ahead and change that 7 to a 6. Change those 7s to a 6, just because I want to get you guys practicing with repeated decimals. If a decimal repeats, we do a special notation called bar notation. When a decimal repeats inside of your calculator, instead of writing that number over and over and over, or that sequence of numbers over and over and over, we're going to do bar notation instead. So here, when we have 2 divided by negative 6, again, we would write it as 2 divided by negative 6. That's going to come out to negative 0.3, and that 3 is going to repeat. So instead of writing the 3 over and over and over again, we put a bar above it. That bar above it lets us know that that number is going to keep going forever. Okay, we have negative 2 over negative 6. Remember, double negatives are going to come out to a positive, so this becomes 0.3, and the 3 repeats. For the next one, we have a negative in front of the fraction. That means we're dividing 2 and 6, and then we're going to put a negative with it. And that comes out to negative 0.3 repeated. And for the last one, negative 2 gets divided by a positive 6. We get negative 0.3 repeated. Again, the only one that stands out as being different is the one that has those double negatives. Having those double negatives is going to create a positive answer. That's it for our notes. Go ahead and pack up.